About 3 months ago, Namaskar Mitro. About 3 months ago, I uploaded a video on how to build an RC car. In that video, I also made an ESP Now transmitter and receiver. Several people suggested that I should not use the throttle and steering on the same stick, and I also realized that it was difficult to control the car with this remote. So in this video, I'm going to upgrade the transmitter by adding a separate potentiometer for steering, which will allow for better control. In my previous version of the transmitter and receiver, I used an ESP32 with a PCB antenna, which gave me a range of approximately 150 meters. However, in this version of the transmitter, I will be using an ESP32 with an external antenna. If you are curious about the range, then stay tuned until the end of this video. To build the transmitter on the breadboard, you will need an ESP32 board, an analog joystick module, a 5 kilo ohm potentiometer, and 4 tactile push buttons. For the receiver, you will need an ESP32 and header pins. And obviously, you will need breadboards and a bunch of jumper wires. Now let's fix the receiver components on the breadboard. Okay, so this is the receiver and this is the transmitter. You can follow these diagrams for connections. Now I will show the process of uploading the code. If you are uploading the code for the first time in the ESP32, then you will have to set up your Arduino IDE and you can follow this article for that. If you also want to get the basic knowledge of ESP Now, then you can follow this article as well. Now open the get MAC address code. Code link is available in the description. Select ESP32 rover module as board, select the right port, and then upload this code to the receiver ESP32. If your code is not uploading, then press the boot button for 1 to 2 seconds when you see connecting on the terminal. After successful upload, press the enable button in ESP32 and you will get the MAC address of your receiver ESP32 on the serial monitor. This is the MAC address of my ESP32, but it will be different for yours. Now copy this MAC address and open the transmitter code. Now paste the MAC address of your receiver ESP32 here in the transmitter code and upload it to the transmitter ESP32. Now open the receiver code, select the right board and port and hit upload. Alright, so the code has been successfully uploaded in the transmitter and receiver. Now let's check the results. As you can see guys, the transmitter and receiver are working fine. Its streaming feature is also working as expected. You can also see the data on the serial monitor. Now to take this project to the another level, I'm going to use the JLC PCB for this project. So first of all, I created the circuit in EasyEDA, converted it into PCB and generated its Kerber file. After that, I log on to jlcpcb.com to order PCB. JLC PCB is a worldwide leading manufacturer of printed circuit boards, offering 1 to 8 layer PCB from $2, and they also offer PCB assembly, SMT stencil, 3D printing service, and many more. Their user-friendly interface makes the ordering process beginners-friendly. To order the PCBs, upload your Gerber file on JLC PCB's website, select PCB settings, and order high-quality PCBs at very affordable price. I ordered the PCB with a black color mask and a white silk screen. Additionally, I also ordered separate PCB for tactile switches. If you also want to take your project to the next level, then head over to jlcpcb.com and order your own PCB. The link is available in the description. Now let's solder the remaining components on the PCB. Alright, so our PCBs are ready. Now let's design and print the enclosure of the transmitter. So our transmitter is ready and finally it's time to give it a test. I have used the same receiver for testing that I built in my previous version. This receiver has a PCB antenna. As you can see guys, our transmitter and receiver are working as expected. Its streaming feature is also working fine, and one of the highlighted feature of this transmitter is its self-centered steering mechanism, which is working smoothly. Now let me tell you about the range of this transmitter. With an external antenna in the transmitter and a PCB antenna in the receiver, I was able to achieve a range of approximately 220 meters. If we add an external antenna in the receiver, we can further enhance this range. In my upcoming RC car video, I'll be doing just that. So be sure to check it out by clicking on the left video. I will see you in that video.